Soil and rainfall. We have already seen how very important it is that we are faithful with what we are given. The soil and rainfall are two of the basic things that any nation is given. If we choose to be farmers, we must learn how best we can be faithful with them. In this lesson, we will be looking at how we are wasting our soil and water. Problems with ploughing. Deep ploughing is a modern farming technique and is very destructive to the natural soil structure created by God. Ploughing can lead to many problems like compaction when the soil becomes very hard. Hard soil cannot hold the water when it rains, and so the rain cannot get deep into it. By ploughing and interfering with the natural soil structure that God intended, we also stress our plants, making them weaker and more likely to get sick. Ploughing contributes to massive amounts of erosion every year. Erosion wastes both soil and water. In Foundations for Farming, we never plough. Rather, we make small holes to plant our seed in. Cover the seed with soil and ensure the soil is covered by God's blanket, which is a thick covering of plant material called mulch. This means that water can travel slowly into the soil when it rains and can go much deeper. The soil will then keep moisture for much longer. The mulch reduces erosion and evaporation. Soil demonstrations. Splash demo. In this demonstration, we are using two small identical plates of soil. The soil is loose, as it would be if it were in a ploughed field. We cover one of the plates with a layer of mulch and then direct a strong jet of water at each plate in turn. What we see is an exaggerated effect of raindrops hitting the soil as they fall from the sky. On the exposed plate, there is a lot of soil disturbance as the soil and water is thrown out of the plate onto the paper beneath it. There is also a marked slumping or compaction evident where the water hit the soil. The other plate, which had the mulch, is very different, and here we see how important it is to have a cover over our soil to protect it from this primary form of erosion. Infiltration demo. We would now like to show you that one of the primary factors influencing why we plough is in fact untrue. The belief is that if we loosen the soil, it will allow for better water infiltration. We've created two funnels. One contains fine soil, as would be seen in a ploughed field or a seedbed situation. The second contains soil which has been disturbed as little as possible after being dug from a virgin area of undisturbed soil. When we pour equal volumes of water onto these two funnels, it is very evident that the fine, disturbed soil does not allow for water infiltration. While in the undisturbed soil, there is very rapid infiltration. The reason why the water does not infiltrate is that the soil structure has been broken down into very fine particles. These particles actually form an impervious layer preventing water penetration, and upon drying, create a very hard, compact layer known as capping. Clod demo. A very visual experiment which can be conducted to show the importance of not disturbing the soil structure through ploughing is the clod demonstration. Here we take two clods of similar soil type, one from a ploughed field and the second from an undisturbed area. Visually, the clods are very different. It can be noticed that the clod from the ploughed area is definitely harder and has fewer pore spaces. When these two clods are placed into a jar of water, it is a general expectation that the harder clod will be more resilient to the water. Amazingly though, as you can see, it is quite the opposite, with the softer, easily broken clod being totally unaffected by contact with water. Thus, as we disturb soil through conventional farming practices, we are actually destroying the natural ability for soil to withstand erosion. Runoff demo. In the final demonstration, we prepared 2 trays in an identical manner. Firstly, placing a layer of stones and then a layer of sand and finally a layer of topsoil. Then on one of the trays, we place a layer of grass. It should be noted that both soils are equivalent to ploughed soil. Each tray has a jar to catch both the runoff water and the infiltrated water. Water is poured to simulate rain and is applied as evenly as possible to both trays. In a very short space of time, water begins to flow off the unprotected tray. This water also carries a large volume of soil with it. The mulched tray has very little runoff, meaning the water should be infiltrating. This is soon very evident as water begins to flow into the jar placed to catch the infiltration. When the jars of runoff water are compared and the water poured out, we are able to see the difference of the eroded soil between the two. Consequences of ploughing. Ploughing is not only bad for the soil structure, it also affects the crop's growth. Here we see the difference between unploughed land and ploughed land. Unploughed soil has lots of nutrients. Roots do not need to grow deep underground to find water. The crop can grow above the ground as its water needs are met. When roots rot, they leave air gaps that can hold water. Small organisms are able to coexist in perfect balance in the soil. In ploughed fields, the roots grow too large as they search for water and nutrients, and there is more crop under the ground than on top. Good organisms in the soil are killed as the ploughing destroys the structure of the soil. When it rains, water penetrates unploughed soil easily and replenishes the water table. But with ploughed land, the water does not penetrate easily and instead causes erosion.